Alright, so number 5 says give the structure of the organic product of the following reaction. Right, so here they give us this molecule. It's a dichlorohexane, right? Molecule. They say they have 1 mole. And they're treating it with sodium iodide, and they have 1 mole of that, and they're treating it in acetone. And they're telling us that the products are C6HClI plus NaCl. It's an aprotic solvent. Acetone. That means that there's no hydrogens attached to the electronegative atoms like oxygen or nitrogen, in this case oxygen. So what we know about aprotic solvents is that larger nucleophiles are less solvated and therefore more reactive. So I is more reactive than bromine, which is more reactive than chlorine, which is more reactive than fluorine, which is usually counterintuitive because fluorine is more electronegative, and you would think it would react with the carbon, with the positive carbon center more quickly. So small nucleophiles are more easily solvated, so are better leaving groups. Show what the solvation is. There's Cl, right? And it's completely surrounded by the positive charges of those methyl groups on the acetone, right? It's pretty stuck in there. Whereas the big iodide ion kinda, because it's so big and its electron cloud is so big, it can kind of spill out, right? And the acetone groups can't really hold it in there that well. So that's why it's more reactive. So coming up here, it's going to react with one of these chlorines. Sn1 is more likely to react with a first degree carbon rather than a second degree carbon because of steric hindrance. This I from the sodium iodide is going to attack right here, and the chlorine is going to leave as a leaving group. There's going to be inversion. So the I is going to come up, these hydrogens will be pushed down. Here we have our chlorine, the whole molecule kind of like inverts. And that's the answer.